Welcome to Spring LIB.
So in first one we have HCl or hydrochloric acid reacting with nickel. So first we will write down the reaction equation or the molecular equation, then we will balance it, then we will write the total ionic equation, and from there we will write the net ionic equation. So let's first write the molecular equation for the reaction. So nickel, it will be in solid state. It will react with HCl, which is water soluble, and it will be in aqueous condition. In the product side, we will have the nickel will react with the chloride to form nickel chloride in aqueous, plus we will have hydrogen gas. So now this is our molecular equation. Now we have to balance it, and for balancing we have to keep in mind that first we balance the metals. For balancing equation, first we balance metals, then we balance non-metals, then we balance hydrogens, and then we balance oxygens if we have any. So this is the regular procedure for balancing chemical equation. So first we balance our metal. Our metal here is nickel, so we have one nickel here and one nickel here. That means we don't have to balance the metal. Now our non-metal here is chlorine, so we have two chlorine here but one chlorine here. That means we have to put it two here, and now we have two hydrogen here and also two hydrogen here. That means the equation is balanced. Now we have to write down the total ionic equation. So while writing the total ionic equation, we have to break the compounds into its ions if that is an ionic compound which is soluble in water, or if that is a strong acid, so, or a strong electrolyte. So if a compound is strong electrolyte, that means it will be completely dissociated into its ions, and we have to write them in ionic form. So since HCl is a strong acid, it is a strong electrolyte. That means we have to write it in the ionic form. It will be in 2H plus, plus we have 2Cl. We have to write it the state also, aqueous, plus 2Cl minus. It will be also in aqueous. And then so nickel chloride is an ionic compound, so it will be also be dissociated into its ions, Na2 plus 2Cl minus, and we have hydrogen gas. Now what we have to do here to find the net ionic equation is we have to cut the common ions from both sides. So the common ions or the spectator ions in both sides, here you can see that chlorine is the common ion in both sides. Just cut the chlorines and we write the net ionic equation. Nickel plus 2H plus and we will have nickel 2 plus in aqueous plus hydrogen gas. So this is our net ionic equation for this reaction, and this is our balanced molecular equation. Now we go to our second one, where we have sulfuric acid reacting with iron. So iron will be in solid form and sulfuric acid, being water soluble, will be in aqueous form, and the product will be ferrous sulfate in aqueous form plus hydrogen gas. So now we have to balance our metals first. So metal here is iron. Iron is already 1 in both sides. Then we have to balance the non-metal. So when we have um, the complex ions, or we have the radicals, or the molecular ions like these sulfate, we don't have to count the sulfur and oxygen separately. We can just count the sulfur ion in total in both sides. So we have one sulfur here and one sulfur here, and we don't have to balance it. And we have two hydrogen here and two hydrogen here. That means we don't have to balance the hydrogen also. That is the mm, the molecular equation is already balanced in this case. Now we have to write the total ionic equation. So iron will react with, since sulfuric acid is a strong electrolyte, it will be completely dissociated into its ions, which is H plus and SO4 2 minus. And in the product we will have Fe2 plus SO4 2 minus. Since it's ionic compound, it will be also uh, dissociated into its ions in the aqueous solution, and we have hydrogen gas. Now if we cut the common ions from both sides, we have sulfate cut from both sides, and the net ionic equation will be iron plus 2H plus in aqueous will be equal to Fe2 plus aqueous plus hydrogen in gas. So this is our net ionic equation for this reaction. Now go to the third one. Here we have hydrobromic acid reacting with magnesium. So magnesium solid will react with HBr, which is aqueous, being soluble in water. And then in the product we will have magnesium bromide, aqueous plus hydrogen gas. Now we have to balance the equation. We have one magnesium in both sides. We have one bromine here, two bromine here. That means we have to put 1 2 here. And now we have two hydrogen here and two hydrogen here. So that is our balanced molecular equation. Now we have to write the total ionic equation. It will be Mg2 plus, oh no, it will be in solid form, the magnesium. Then we will have 2H plus from the HBr. Since it's a strong electrolyte, it will be completely dissociated into its ions. It will be 2H plus 2Br minus, 2 hydrogen and 2 bromide ion. And then in the product we will have so since it's ionic compound, it will be also be dissociated into its ions, a soluble ionic compound, Mg2 plus 2Br minus, and we have hydrogen gas. All right, now we have to cut our common ions from both sides. So a common ion here is bromide. We just cut it and write our balanced equation, which is magnesium in solid plus 2H plus aqueous. It will give us Mg2 plus aqueous plus hydrogen gas. So this is the net ionic equation for this one. And finally we have acetic acid reacting with zinc. So zinc, it will write it as zinc, which will be in solid And then we have acetic acid, whose formula is Hc2H3O2. And since it's also water soluble, it will be aqueous. The product we will have zinc acetate, since the charge on acetate ion is -1 and on zinc it's +2, it will be ZnC2H3O2 whole bracket 2. It will be also aqueous. And then we will have hydrogen gas. Now we have to balance it. First we have to balance our metal. So we have one zinc here, and we can count the acetate ion in total. So we have one acetate here and two acetate here. So that means we have to put it 2 in the reactant side. Now we have 2 acetate in both sides. Then now we have 2 hydrogen here, and we have 2 hydrogen here also. So this is our balanced molecular equation for this reaction. Now I have to write down the total ionic equation. So let's write it down on a new page. So we have zinc in solid. Then so acetic acid is not a strong electrolyte, it's a weak electrolyte. That means it will be not completely dissociated into its ion. So we will write it in the same this form. So write it to Hc2 H3O2 in aqueous. The product side, so our zinc acetate is an it will be dissociated into its ions. So we will have Zn2 plus aqueous plus acetate ion C2H3O2 minus, and we have 2 acetate. That means we have to put a 2 here. It will be also in aqueous, and finally we will have hydrogen. Now here we can see that we don't have any common ion in the reactant and product side. We have zinc as solid here and zinc as ion here, and we have this as a intake compound, not in its ionic forms since it's not a strong electrolyte. But zinc acetate being a strong electrolyte will be dissociated into its ions, and we have hydrogen gas. So since there is no common or spectator ion in both sides, so the total ionic equation for this reaction will be its net ionic equation.